How to build a model steam engine. Stuart Models Victoria, Part 2, Making the Bed. I'm starting with the bed because it's a logical place to start. You need to have something to put the parts on, and if you don't make the bed first, you'll just end up with lots of parts on the bench. This first part of the job is very good practice if you've never used a file. A file is quite an amazing piece of equipment, and when you see what some people can do with a file, you wonder why they bother with machine tools. This clip is now running at double speed because it's a bit of a tedious operation to show on a video. When using a file, you need to learn how to control the file, and you must hold it flat against the work at all times. If you don't do that, you will round the edges, and that looks really bad. The best way to learn how to use a file is to get a piece of metal and a file and file the piece of metal. You'll probably make a complete mess of the first piece of metal that you file, but after a while the penny drops and you learn how to control the file, and it's like having a handheld milling machine. And the good news is, cast iron is a very easy material to file. The son of a friend of mine is an apprentice mechanical engineer, and one of his projects at the college was to file up a piece of steel to a set shape from a drawing, and he was finding this incredibly difficult to do. So I gave him a few pointers, and I don't think he was that interested, but in the end, when he submitted the work, he got a pass, which was good. Not all files are the same, and I'm not an expert on types of files. I never had the benefit of an engineering training. I chose to study music instead. So I do generally approach engineering like a musician. I do not have an engineer's brain. But what I do have is lots of common sense, and that's what you need. I've stopped filing for a while because it's a very hot day and I really was starting to overheat slightly. I'd just like to point out that on this file there aren't any teeth on one side and plenty of teeth on the other side. This is a practical demonstration of the benefits of only having teeth on one side of the file. I'm currently filing the inside edge of one of the sections of the bed, and I'm using the file with the cutting teeth towards me, as you can see here. The problem is, as I get close to the vertical part of the bed, if I carry on doing this, I will file a groove where I don't want a groove. And when I file the vertical part, I don't want to make a groove in the bottom part that I've just filed. So all I'm doing is turning the file over, and then there are no teeth that can file a groove. So I can go right up to the vertical part, or the horizontal part, depending on which part I'm filing, without marking either surface. On the main cutting areas of the file, the broad part, one side is coarse and one side is fine. So in this one simple tool, you have quite a lot of flexibility. Then of course there are the different filing techniques. This is called draw filing, when I'm using the file from side to side rather than back and forth. There are quite a few variables when it comes to filing. You can either put a lot of pressure on and remove a lot of metal at one go, or you can move the file faster and put less pressure on and remove slightly less metal, and then you can finish it all off with draw filing, which gives the part you've been filing a very smooth finish. Shock horror, what's this? This is a linisher or belt sander. And just like filing, once you get used to how this thing works, it's very useful, because obviously it imparts a ground finish to the work, but you have to be very careful. This is dicing with death. If I do this wrong, I could remove a chunk from the casting. But I'm well versed in the use of a belt sander or linisher because I've used one for years, and it's certainly less energetic on a hot day than filing. So I think it's time for a cup of tea. With the tea now coursing through my system, I can resume the filing process with much more enthusiasm and general energy. I only used the belt sander to remove a great big lump of cast iron on the end of the bed. I could of course have used an angle grinder, but they're a little bit brutal for this job. The humble file is the best tool to use. And the pot of tea that I had is really working, because I'm filing incredibly fast at the moment. Well no, actually of course the video is speeded up to just get through this process a little quicker, but in reality, even in real time, it doesn't take that long. In this clip I'm using a needle file just to clean up the inside edges. I'm only using the needle file lightly because I don't want to make a groove in the corners. I'm using the needle file just to add a little bit more definition in these areas of the bed. So why do we use castings and go to all this trouble of cleaning up a casting? I could manufacture this part using bar stock and get someone to weld it together and then machine it, and it would look pretty much the same, but it wouldn't. It would not look like a casting. I'd have to spend a lot more time making a bar stock bed look like a casting. And a full-size steam engine of this type would not have a bar stock bed. It would be a casting, and castings are not perfect. A lot of the time, castings need quite a lot of filling to make them look good. If you own a lathe or a milling machine, have a close look at the bed casting. I'm not suggesting that you go up to your lathe and start chipping off the paint on the casting to look how it's put together, but you probably would find that the casting that makes up the bed of your lathe probably started off life coming out of the mould quite rough. But by cleaning it up and filling the casting, that's why the cast bed parts of machine tools generally look so good. You'll be pleased to know that not all operations on this steam engine build are going to be done by hand. Quite a few, of course, will be done on machine tools, but I'm not going to presume that everyone has one of these. This is my old milling machine. It's not terribly good, but at least I have it, and it is a milling machine. Milling machines are expensive and these are very cheap. So if you haven't got a belt sander and want to build a steam engine like the one I'm showing you how to build, it's probably a good time to buy one. Health and safety warning. Using machine tools can be very dangerous. Always read the manufacturer's instructions and wear protective equipment. What I'm showing at the moment I'm sure will upset some experts. This is not model engineering. This is not machine tool work. No, it's a belt sander. Because I really am not presuming that everyone who wants to build a steam engine owns a big milling machine. It would be very nice to have a really big milling machine in the workshop, then clamp the bed to the milling table and take a facing cut to get it nice and flat. However, I can get it nice and flat on a belt sander or linisher. It all depends on how you approach the job. It's down to feel. Feel is something that you can't really teach, it's something you do have to develop. And of course practice makes perfect. If you are following this series and building a steam engine, don't worry if you foul up. The worst case scenario is you will have to buy a new part from Stuart Models. One vital piece of equipment that you need in the workshop is a flat surface. This is a surface plate. It's not a proper surface plate. It was the table that came off an old engraving machine. But it's flat, and when I put the bed of the Victoria on the surface plate, you will see that it doesn't rock about. It is very flat indeed. And if you don't have a surface plate, you could use the lathe bed. That's generally pretty flat. Alternatively, you could get hold of a piece of plate glass. That's also flat. I think it's time I wash my hands. Working with cast iron is a very dirty job, but I like getting dirty sometimes. Right, back to the filing. This time it's on the bench and I'm using a very fine needle file. All I'm doing with the needle file is removing any sharp edges. While the casting is on the bench, I'm having a quick look at it. And a word of caution here. When drilling the holes in these mounting lugs, do not assume that these cast-in marks are in the centre of the mounting lugs, because they often are not. I'm not quite ready to drill the mounting holes in the lugs just yet, and instead I would like to show you this really useful piece of workshop equipment that is as old as the hills, and this is called a height gauge. And there are many different ways to use this. For instance, you can use one of these gauges for marking out. All you have to do is use a ruler down onto the surface plate and set the gauge pointer to the measurement that you require, and then you can use it as a scribing block. For this application, I don't need to use it as a scribing block. I'm using it in this case to just compare the height of these mounting points on top of the bed. And these haven't been machined at all. I've just cleaned them up on the linisher. And out of curiosity, I'm just checking how far out they are with each other. And you will note, as I mentioned earlier, I'm not reaching for the milling machine. It will be a very simple job to now clamp this casting on the milling machine table and just skim across the top of these mounting blocks. So if you do have a milling machine and know how to use it, that's the way to machine this bed perfectly level. But what if you don't have a milling machine, as I mentioned earlier? Well, there are other ways to do it. I always liked the teachings of LBSC, Lillian Lawrence, who wrote in Model Engineer. I spent a lot of time studying the way he approached things, long before video, long before the internet, and long before computers. In the days when I used to read the instructions that LBSC put in the Model Engineer magazine, I would be in my early teens. LBSC had a style of teaching that I always found very easy to understand and very encouraging. Some of his contemporaries, however, didn't quite see it this way, and they wrote in an odd kind of a style, sort of a one-upmanship style. Oh, you need to have one of these and you need to do it this way, and if you don't do it this way it's not going to work, and you need one of these and one of those and one of the etc., etc. And the attitude that came across in the writings of certain people really did intimidate me as a beginner. But LBSC's style was entirely different, and that made me think, yes, I can do this. And now, all these years on, and I'm sure I'll be contradicted on this, but it really doesn't matter, this is not rocket science. Well, certain aspects of engineering could be classed as rocket science if you were making rocket engines, but I'm making a steam engine, which is slightly different. So after levelling the bed, as I showed earlier, using the belt sander, and checking that it was level on the surface plate, I'm now using the micrometer to accurately measure the distance between the bottom of the bed and the top of these metal pads. And there's about a 5 thou discrepancy, and that's from a belt sander. Oh, and a file. Yes, I used a needle file as well. I just wanted to show that it is at least possible to get very near the perfect dimensions that you require using just a belt sander and a file, and some sandpaper, and a surface plate, and a surface gauge, and a micrometer. I'm not being flippant about this. You do of course need certain tools. It's essential that you do have some twist drills, and also it's essential to have taps and dies. And of course a drilling machine is quite a useful thing to have as well. I'm currently using my drilling machine with a centre drill fitted in the chuck to start drilling the holes in the mounting lugs. Fitted in the cross vise on this drilling machine, and I must say that this cross vise is not accurate in any shape, way or form other than the fact that it is level. I only have this cross vise as a safety feature, just to hold pieces of metal, not big ones like this. This is not going to spin round with such a small drill. But for drilling small pieces of metal, I do not want them to spin round and cut my fingers, because as I'm a keyboard player that would cause me great problems. And you may notice that there's a piece of metal sticking up between the jaws and the piece of mahogany that I'm using as a pad to drill on. And in this situation I'm just using this piece of scrap metal as a stop, so that I can push the bed against this stop when I'm using the centre drill. And now that I know that all the holes are in the correct place, I've fitted a twist drill. It's a 5/32 twist drill. The finished size will be 3/16, but if you read the text that is on screen, it explains why I'm doing this. And the reason for drilling through with a smaller twist drill is because if I drilled through with a 3/16 drill to start with, then if the holes were in the wrong place, I would have to file them out and really enlarge the holes, and subsequently the mounting lugs would be weak. In this clip I'm using a square just to check how accurate these holes are, and they're pretty accurate. I'm quite pleased. One of them is a fraction out, and I really do mean a tiny fraction. When I look at the mounting lugs from underneath, they're not all the same shape anyway. But I'm going to use a needle file and just slightly correct the hole. I don't need to do this, may I add. I'm doing it for the purposes of the video and not because I am incompetent. And as can be clearly seen by the small amount of iron filings on the bench, I'm hardly removing any material at all. And now it's back to the drilling machine to drill the holes in the lugs the correct size. This is a 3/16 inch diameter twist drill. Why 3/16 inch? That's clearance size for 2BA, because I'm going to use some 2BA studs to hold this bed down onto the finished plinth. And so to recap, I've managed to make this part by just using a file, a belt sander and a drilling machine. And the base is more than accurate enough to support what it's going to need to support when the engine is completed. And that's it for this episode. Thanks for watching, and I hope you found it useful.